Thank you, Paula. Interesting that Paula mentioned just now, is there a problem with Malaysian Airlines reliability or safety? Because for last year or 2 years ago, we experienced two major incidents. One lost an airplane, and the other one was shot over Russian-Ukrainian airspace. Right? So I don't know whether that is really reliability problem or something else. Right? Political, maybe. Right? Okay, it's nice to be here. My name is Ali Azizan. I'm from Petronas. Today, I will share what we have done to improve our safety and asset management. It's nothing to do with the best practice of reliability or CIS that Paula mentioned just now, right? I'm just going to share pictures of what we did and so on. So I hope, I have two big challenges in front of me right now, right? One is to keep you guys from falling asleep. And another challenge is for me not to fall asleep also, because my body clock is still thinking 3 o'clock in the morning back in across the globe. Yeah? So this what I'll try to cover, right, for this afternoon. Just a brief introduction. Right, I'm from Petronas, which is the national oil company of Malaysia. Right, for those who have been to Malaysia, right, you can't miss these twin towers, right, the tallest twin towers in the world, and I'm located somewhere here, level 23. Right, there's 88 floors. So we are a fully integrated oil and gas company, right? Fortune 500 company, right? And we have presence in 20 countries. It used to be more, right? But we try to reduce our presence. Right? Now we have a presence in Canada, but none in the USA. Right? We have in South America, all over Africa, right? Of course, in our own backyard, Brunei, Vietnam, Thailand, Myanmar, China, and Australia. Right? So we are into the whole scheme of oil and gas, upstream, downstream. Right? This is where I'm from, the upstream business, right? And we also have our downstream facilities. Okay, what I mentioned just now, right? I'm just going to share how we explore new technologies, evaluate technologies to improve safety and reliability of our assets, right? So we embarked on this initiative or project sometime in 2014, right? Basically, it's just to assess long-distance communication, wireless communication, right? Using ISA 100. And another objective is to test the performance and interoperability of wireless gas detector, right? This is a new generation of gas detector, right? Normally we have a wired gas detector, but sometime 2 years ago or 3 years ago, right? There was a wireless gas detector, right? So this is what we did, nothing unusual, right? We have our offshore wellhead platform, and we have the so-called mother platform, right? And we're trying to test the communication, right? Nothing special here. It's just that normally we communicate over 200 kilometers and so on, right? Using VSAT, using the digital microwave radio, so that is a typical setup. But in this case, we are using ISA 100 wireless, right? To just communicate over 5 kilometers of distance between the wellhead and the main platform, or central processing facility, right? So typically, wireless network for the process instrumentation will go maybe 500 meters, right? So to achieve 5 kilometers is something need to be tested and proven, right? So that's what we did, and together with that, we also install these wireless transmitters, wireless gas detectors. Right? So the motivation is really to improve, to find cost-effective solution to improve safety, to improve asset performance through monitoring and so on. Right? So that's what we have, demonstrate reliability, interoperability, and see whether the full wireless functionality can be achieved over long distance to improve asset management and safety performance. Okay, a bit of background on project. We installed this in South China Sea, right? Called the platform called Zuhal, unmanned platform, a small minimal facility type of wellhead platform, right? If you are not familiar with this region, yeah, Malaysia is here, right? There's the Borneo Island, it's also part of Malaysia, and the Vietnam or the Philippines around this area. Right? So we chose this site. It's just not to say coincidence, but we have the opportunity to test the long-distance wireless. Right? Our technology supplier or vendor have the capability, have done the testing, but it's over land. They have not done it onshore. And since we have, at that time, ongoing fast-track project, right? So we say, why not we install ISA 100 and see how it can perform over the 5-kilometer distance, right? And also, in this, we have a very minimal facility, right? Not to say safety is not important, but then safety is always number one. But you have to evaluate and balance out, right? For minimal facility, we have a very small system. Then maybe you don't install very sophisticated gas detectors network. Maybe you just use a fusible plug and things like that for safety reason, right? But since we have wireless gas detector, right, with all the promise and so on, so we say why not we try out the wireless gas sensor together with this. Right? So that is the bit of background of the project. So we did this in May 2014, right? We installed, commissioned, and so on, and we began monitoring this, I think, in July 2014 until 2015, January, right? And as you know, offshore platform, right? The environment and so on, that is a big challenge for this wireless type of instrumentation. Right? So this is the system architecture, briefly. Right? We have the sensors, right? And then we have repeaters, right? And that signal is transferred to the main platform, right? Where we have our access point and gateway, and goes into the control system, right? So basically, we have wireless ISA 100 wireless hardware, right? Gateway, access points, pressure transmitters, gas detectors, repeaters, and in this case, we have to use high gain antennas, right? So instead of the 2 dBi or 5 dBi, we use a 15 dBi antenna for this. So here's the picture that I mentioned to you just now, right? So just sharing you some pictures, right? Nothing technical about this, right? So that's where we install our pressure transmitters, right? This could be any wireless device. In this case, we just use pressure transmitters. It could be Bentley wireless vibration sensor, machine monitoring, wireless machine monitoring devices, condition monitoring devices, and so on, right? And wireless gas detectors. Right? So there is a very interesting development, because with this wireless installation, it's very flexible. You can install it anywhere, and it's portable, right? It's portable, is the thing. Because it can be installed when you need it, right? For example, you are trying to do some extra work on that one, right? On that area, then you need extra coverage of gas detector, then you can install this one. As long as the wireless infrastructure is already there, then it's very flexible. So we have 3 units of this installed near the multi-phase flow meter, I think the wellhead area, right, and so on. This is another picture. I think this is the repeater, not the gateway, right? And we have the HMI station over on the main platform. Okay, some of the result. We are quite pleased with this result, because we monitor the RSSI and the PR. RSSI is basically the received signal strength indicator, right? And the PR is the packet error rate, right? So based on our 6-month trial, right, over the 5-kilometer distance, we found that the signal strength is acceptable, right? In fact, it was stronger than acceptable, minus 60 dBm, right? And packet error rate for this one is 0, right? So that's good. And we installed 2 devices, two manufacturers, right? One is the gas sensor from Gas Secure, which now bought over by Draga, right? And the other is basically Yokogawa wireless system. And we found that the 2 devices can play nicely. There's no problem of interoperability and so on, right? So that is a good indication. And also, I think later on, Yokogawa becomes the exclusive distributor of gas secure products, right? Because they have proven, they have proven that they can work nicely. So these are some of the what do you call it, monitoring that we can do, right? Of course, you can do this over wired, but we now use wireless, right, for indication and so on, right? As I mentioned before, this may not be pressure monitoring. It can be any parameters that you want to monitor wirelessly, right? And this one, of course, the gas detectors, right? And together with this, we have all sorts of the diagnostics for the transmitters or wireless devices, right? Same thing for the gas detectors, right? And in this age of IoT and so on, right? So these are the important diagnostic that we can use to up our to maintain our uptime, reliability of our facilities and so on. Okay, in conclusion, right, the tests have proven the capability of asset management, improving safety via wireless implementation. Right? So during our 6-month test period, we saw that the wireless system stays interoperable, right? And the communication is reliable over the 5 kilometers distance in offshore environment. Right? And the wireless nature of the system, it took much shorter time to install and commission. Right? And the wireless implementation offshore has proven to be beneficial, right, in terms of safety, operational facility, and cost saving. Right? Cost saving, yeah, because we took less time to install, to design, and to install this thing. Right? So we also saw that ISA as ISA 100 as a wireless standard able to deliver the full functionality as promised in the standard. Okay, and lesson learned from this, ISA communication has been proven to be reliable, right? Even over the 5-kilometer distance, right? Because typically in a process plant, you go maybe 200 meters, right? I mean, heavily steel plant, and maybe you are limited to maybe 50 meters, right? Without line of sight. Right? With line of sight, you can go maybe 500 meters. But in this case, we go 5 kilometers. And yeah, the RSSI and PR is a good mechanism to gauge the signal reliability. And the feature of ISA, where you can have mesh or star or combination of this, give more flexibility in terms of the implementation of the wireless network system, right? And interoperability, as shown by the two vendors in this test or pilot, we see that the plug-and-play mechanism, simple integration of different vendor products achieved in the network. So I think that's all for my presentation. As I promised you, it's going to be short